go ahead and get started. So just confirm that you guys can see my screen and everything's okay. Cool. And because we're a small number, I will ask you guys if there's anything that I talk about that you do not understand, feel free to stop me in between, but just unmuting and asking a question so that we can interact on that particular thing as much as possible. But I will give you guys a roadmap overview of data science. And at the end of the day, at least you'll have a clear map out of what you need to follow to get into a typical data science career. So we did have slides developed already, but because I'm trying to make this interactive, what you're going to do is I'll just ignore the slides and we'll probably just map it out from how it's supposed to be from the beginning. So you'll just see me doing a lot of typing just to make this as relatable as possible. I think the slides are okay. I don't want to make it as fluid as the slides come to be. Cool. So let's talk about data science careers. So typically speaking, what is data science and what does it entail in the first place? So when you talk about data science, you usually talk about a pillar of three things, and some of you might be familiar a lot with this. And whenever we think about data science, one, we always talk about a lot of math and statistics. So at the end of the day, data science is really based on a lot of math and statistics. Most data scientists will tend to have a statistical background most of the time. The math is quite essential because that's what we use to optimize some of the machine learning algorithms. So having a good base with mathematics and statistics is really good. I'll talk about some of the key topics you want to cover when it comes down to math and stats as well. But usually we lean more towards that mathematical and statistical aspect. Cool. The second skill with data science is really the programming bit. So do you understand, do you have programming skills? And can you implement models with languages such as Python or R? So the typical programming languages that we see with your typical data science career will tend to be Python, which is really winning over the race. Some of you might be familiar with R, which will tend to be used more in academic setups as well. And you could also start seeing some upcoming languages coming up, Scala, where if you're a data engineer, probably there's something that you might start seeing now and then. But Python is also still good for data engineering anyway. So those are pretty much some of the programming languages. So probably what I can adjust here is to understand the brackets. So I'm going to talk about those brackets very well so that we are able to understand them. Let me just add in the font here. Cool. I hope you guys can see quite clearly. If I need to zoom in, just let me know. Okay, that's okay. So this is now just your typical data science pillars before I talk about the career opportunities that are available in data science. So math, stats, and then programming languages. So before I go to the third pillar of data science, we need to understand that when you only know math and you know a programming language, what we call this as part of the pillars, that is what forms up machine learning. Machine learning is when you're using your programming skills and mathematical skills to implement models that are able to give you particular predictions. So machine learning is really more of a good mixture of a lot of math and programming. And you'll see that a lot when you get onto your data science thing. However, knowing machine learning by itself does not necessarily close off data science as a career. I think one of the most key aspects with any data science career is having domain knowledge. On whatever, what would I say? You need to have domain knowledge on the models you're creating, or rather the data projects you're working on. So a good example is if I'm a data scientist, right? And I have a financial background. Let's say I have an insurance background. I know how to detect insurance fraud in one way or another. I'm very vast in insurance. Then it's very easy for me to be a data scientist in the insurance field because that domain knowledge in insurance is really very key. It's very hard to just go ahead and build machine learning algorithms when you don't understand how to clean the underlying data, when you don't understand the biases of any particular domain, and that's usually a key thing. So if I already have a medical background in one or another, it makes it easier for me to become a medical data scientist. So these are people creating ML algorithms that can detect cancer early, so things of that sort. Whereas someone who just knows a lot of Python and math and statistics would not necessarily be fit to work on models that are more healthcare based, like involving X-rays or cancer cells or things of that sort. So domain knowledge is really a key thing. And this domain knowledge could range. It could either be your business domain knowledge, which is where a lot of data scientists end up being. So you could either have marketing domain knowledge. These are some of the common domain knowledge areas that we see for a lot of data scientists, because these are some of the areas that involve a lot of analytics as well. But usually have some niche domains that if you already had this as your base career, it's always nice to explore data science as a way for you to move up that particular career. So think about medical, think about things such as sports, right? Moneyball was a very, very interesting aspect. Right now, when you get to the sporting world, pretty much all teams are using data science and AI models to be able to identify and kind of just predict the potential of players at very young ages. So we're seeing a lot of data being used in the sports industry. It's very hard for you to use that unless you have that sports domain in you. And when you talk about domains, there's a lot of areas we could talk about here, and it's just about that you want to apply your data science skills in a domain that you already have base knowledge on. Cool. So when I combine math and statistics, we've said we have machine learning. However, one thing that you guys already know is when you are already versed in a particular programming language and you have a domain knowledge in a particular niche, then usually that's your typical software development. So those are your typical software developers. So let's take an example of a tool like MailChimp. So MailChimp is a marketing software as a service tool. So people subscribe to that. And it's entirely online. So it is software. So for someone to be able to build a tool like that, one, definitely you need a programming language as a base, because at the end of the day, you're building a software. But if you don't understand the underlying marketing concepts that people need to implement on your email automation software, then that tool is useless. And that's why we always say, even for software dev, you want to have a bit of domain knowledge and combine that with your programming skills to be able to get that. So that's like the mixture of the two. And then we have a mixture of math, statistics, and domain knowledge, and that's our traditional research. Traditional research. And this would usually be that. So if you only focus on two of these pillars, you can decide to get into either machine learning, or you go into software dev, or you do your traditional research that we still that's quite common across academics as well, where you use more of your math and stat skills and your domain knowledge to be able to do your typical research, whether that's medical research, sports research, business research, so on and so forth. But that sweet spot that mixes all these three together is what we call data science. Cool. Now you might be asking me, so what are the careers that someone can now go ahead and get as a data scientist? So the base career that a lot of people end up having would usually be becoming a data analyst for a particular company. Most of the time, data analysts will tend to work under business intelligence teams, right? And you're just analyzing a lot of data, you're cleaning a lot of data, and you're mostly handling data that's able to give the business particular insights and allow them to make decisions better. So that's one career pathway you can take up as a data analyst. In fact, this is really the one where a lot of junior data scientists will end up taking up because most of the time it does not involve a lot of machine learning. Cool. You could also decide to become a general data scientist. So general data scientists will tend to work a lot on data analysis, but they usually go an extra step and work on a couple of machine learning algorithms. But once again, the bulk of the work will still be on data analysis. It will still be on generating insights. And once in a while, you'll work on a machine learning model to make a prediction. Now, what I'm saying would differ from company to company because people do mix up these terms a lot, but I'm just giving you an idea of what this is. Cool. Another common pathway in data science will be becoming an ML engineer. So unlike a data analyst who's mostly concerned with data wrangling, that's the cleaning aspects, right? Trying to get data from the source, cleaning it a bit, trying to do a couple of analyses, and you could use Excel or you could use Python for this. and generating insights off of it, ML engineers have a very, very different approach to data. Yes, some of them will end up working a lot on doing the cleaning. That's usually expected. Anyone who's working in data should be prepared to work a lot on data wrangling. There's no two ways about it. But ML engineers will mostly have a specialty in designing models, right, or fitting models for predictions, whether you're doing your models for regression or for classification or clustering. We'll talk a bit about this today. Probably not in depth because this is not a data science class, but rather a roadmap overview. Or even just doing your deep learning models on a tool such as TensorFlow. So most ML engineers will be in charge of building those models, right? Some of them might also be in charge of preparing the data for the models. But more importantly, ML engineers also need to be well versed with how you can deploy this model into production. A good example would be an application such as YouTube, whereby on YouTube we have an ML engineer. We have a couple of ML engineers who've worked on the models that, or rather the recommender systems for your videos, which is entirely machine learning and deep learning when you think about it. And then they also deploy this so that it can be integrated into the YouTube application, such that anytime I watch a video, right, we update up that model. So now I'm getting a bit into data engineering a bit. But every time I watch a video, the models that are able to recommend the next video for me are usually mostly pushed out by ML engineers, and most of the time also deployed by the same people. Cool. Another one will be people who are data engineers. That's usually another core aspect when it comes down to data science as well. So for data engineers, these people are in charge of data pipelines. A lot of data engineers will tend to work mostly with databases. So how does the data come into from the database, right? How do we make sure it's cleaned pretty well so that it can be served to the models? In fact, the most ideal data science team will be a team that has a data analyst, an ML engineer, and a data engineer as well. So the data analyst will be in charge of the sort of process for data cleaning that they'll be going through, sort of insights that people need to use. Most of the time, we'll call this a lot of exploratory data analysis, whereas the data engineers will be in charge of how do we source the data, so how are we collecting it. So a good example is on the YouTube app. How are we collecting data from that application? Those are things such as the watch time, right? What video did you click on? What video did you click on next? How many comments, how many likes? So think about all the different data points that we need to collect for whatever the recommender systems that YouTube uses. What are the data points that needs to be fed there? So we need to worry about how that is collected. Second of all, we need to start worrying about how that is cleaned. Because this data is not coming as a clean CSV, it's coming straight up from an application. It's usually a lot of bulky data in the first place, so you need to know how to handle big data in the first place. So you're trying to create a proper data pipeline for collection, cleaning, and most of the time you'll end up using tools such as Apache Hadoop, PySpark as well, Apache Kafka. So it's usually slightly technical, but most data engineers will tend to be quite vast with how to handle databases and how to handle big data using such Apache systems. Cool. So these are pretty much some of the common data science careers. Once again, they might have different names in different areas, or you could end up seeing some people who work in data science, but they're still working under business intelligence. But I would say the four I've talked about will tend to be the most common, where the most general one will be that general data scientist who pretty much has an eye across the entire pipeline of data science. Cool. So far, so good. Any questions for me or any clarifications? Any questions or clarifications? Cool. Now let's talk about the data science pathway. Once again, I'll also try to make this as interactive as possible. I don't know how many people I'm with at the moment. If you have a question, feel free to let me know. I'm here to answer all questions. And then we'll share the resources right after the workshop. Okay, so let's talk about the data science pathway. So we already have an idea of the pillars of data science. We've talked about math and statistics. We've talked about programming. And we've also talked about having a clear understanding of your domain. So when I'm talking about this particular data science pathway, domain aspect, because once again, domain understanding will be different. If I'm a psychologist, I need to go through a very different pathway. If I'm a doctor, that's a totally different pathway. If I'm in business, that's also a very different pathway. So I'll only talk about what are these programming skills and math statistics skills that anyone needs to jump into when they're thinking about data science. And then based on your already existing domain knowledge, you can start applying your data science skills in that particular pillar. So for any data scientist, we usually recommend that you start off with programming. And programming is usually your core thing, and typically the most recommended language for a lot of starting beginner data scientists will always be Python programming. This is because Python tends to have most of the libraries that we use for data analysis, and it also has a lot of the libraries that we use for machine learning. So Python has been the language that is fully resourced for a lot of data science tasks as well. And a key thing about Python is it's an easy to learn language. It's a high level language, very, very easy to learn as well. And it means that you will not get stuck most of the time with Python as you would with your compiler languages most of the time. But the main reason why people opt for Python, one, it's an easy to learn language, and it also has some of the most libraries that are essential when it comes down to your typical machine learning tasks. Cool. So under Python programming, you definitely want to learn a bit about the basics. So for those of you who are programmers, you probably understand what these basics are. So of course, you want to understand how do we work with Python functions, how do you do a bit of loops. So those are the typical ones. Let's talk about conditionals. We also have the idea of variables, which is probably the first thing you'll end up learning, expression statements, and so on. Second thing you want to go ahead and learn with Python would be data types. Very, very essential. There's no avoiding data types in any programming languages because you'll end up working with this whenever you're working on that language a lot. So these are strings, which is your typical text data. Let's talk about lists. However, for data science, we'll end up using arrays more of the time. Things such as dictionaries as well. Files, how you handle files as well is very, very key because you'll be importing data from different files. I think I might not, I might have missed out on tuples. So you probably want to learn a couple of the typical data types as well, whether that's sets. I think I've mentioned some of the most common ones. Cool. Now, what I've talked about will usually be your base. That will usually be your base programming skills, or rather, that's like the beginner to Python. However, when it comes on data science, we're really not going to get fully advanced so that we start doing web development with Python here. So we want to start focusing our knowledge. But before we focus our knowledge, I always recommend object-oriented programming to anyone who's learning a programming language. It's really very, very key. And just to have our data bias over here, I will go ahead and recommend understanding how to use web services with Python. So what do I mean by using web services with Python? This means, do you understand how we can work on web scraping? Here you'll be using a library called Beautiful Soup for web scraping. Do you understand how we can work with regular expressions on Python as well, which you'll end up using a lot for data cleaning? And also, you also want to get a bit, not a bit, but a proper understanding of APIs as well, because at some time you'll tend to source data from application programming interfaces. So that's a very, very key thing when it comes down to Python. So we're talking about learning the basics, expanding your knowledge into data types, doing a bit of the advanced Python aspects, which will tend to be object-oriented programming, a bit on modular programming as well. So these are more Python focused as well. Also understand pretty much all conventions that come with the language. Yeah, so you just want to have a proper understanding of the language pretty well. And these are more of the advanced modules there. So having such an understanding gives you that. But for data science, I would always recommend that you also give key focus to how you do web scraping with Beautiful Scoop or Request Library. Understand how you can use regular expressions with Python, and also make sure you know how to handle APIs with Python in the first place. So that's just a general overview of what that programming aspect would be. Any questions for me so far? Any questions? Cool. If you do have a question, feel free to drop it on the chat there, and I'll be able to handle it as we go ahead. So they're saying they need access for the link shared. Kindly ignore the Jamboard. What I will do is all the things I write down on this slide, I will share with you guys, and you'll also have a copy of this video recording. Okay, so once I have a proper understanding of Python programming, what's the next step for me? Cool. I think I've answered this question, Kristen. So what are the skills needed for data science? I think I started with pillars. I did start with the pillars for data science, that is math, statistics, programming languages, and having a domain knowledge. And now I'm breaking it down into some of the different things we need to cover for your data science career. So that's why I've talked about your data science pathway, and I've started with Python programming as a key skill. One, you can also learn R programming as an alternative, but I would recommend Python as the best place to start. So I'm going through the skills one by one until we get to the end. Cool. Two, so what's the second thing we definitely need to do when it comes down to your data science pathway? So the second aspect now is expanding onto your Python knowledge, and we'll be expanding our Python knowledge particularly for data science now. And this is whereby we'll learn more about scientific Python. But I like calling this more of like Python for data science. Or let me call it Python data analysis. Now here you'll start seeing me mention some of the common things you might have heard when you go through data science articles as well. So with Python data analysis, what do we need to cover here? So you have an idea of how to program with Python. Now we want to improve our potential, rather our skills in using Python for data analysis in particular. So the first thing you'd probably want to learn about here, not probably, very, very important, is NumPy. So far, you'll probably be okay working with strings, lists, dictionaries, files, and tuples. However, we always want to work with arrays when it comes down to data science. They're vectorized, it makes our work easier and faster. The good thing about the NumPy library is also based on C, which is a faster language than Python as well. So implementation, executing sort of actions with NumPy arrays. So let's say when I have a list and I want to add numbers on one list based on their column. So think about an Excel column, and I have a second Excel column over here. If I want to add them both, right, with a typical list, I have to loop through them. I have to add each and every single row together, till the end. However, for NumPy arrays, they are vectorized. So I wish I could now get to my Jamboard a bit. So let me come out here and talk about vectorization a bit. Okay, so that's a sticky note. I don't know how to draw on this one, so I'm pretty new here. So let's say we have item 1 and item 2. We have that and that. We have that and that. Cool. And then I'm probably going to draw a line here and call this my first vector. Yeah. And then I'll call this my second vector. Cool. Now, in the Python programming language, if I wanted to add these two vectors together, so when we add these two vectors together, it means that this item 1 will be added to item 2, and then we get the end result over here, which will be item 1 plus item 2 very easily. Cool. So we want to add this and that, that and that, that and that, and so on. So imagine you have vectors of that have a length of 100 plus, 1,000 plus, at times 1,000,000 plus, based on the size of your data. So with arrays, you can perform this vector action very, very fast, whereby elements are added to their corresponding items as well. So anything in index 1 is added to the next thing in index 1 very, very fast, at the same time as index 2 being added to the index 2 of array B. So let's say we have array A and you have array B. So with vectorization, A1 and B1 are added at the same time as A2 and B2, so on and so forth. So this sort of execution will be faster as we get our end result of that addition, as compared to when I work with a typical Python list, whereby I have to do a for loop, where I say for every item in this list, so if the item is in index 1, I want to go ahead and add it to the item in index 2. If the item is in index 2, I want to go ahead and add it for the item in index 2 on B as well, and so on and so forth. So with a for loop, executions are being done one by one. Whereas with vectorized functions or vectorized executions, they're being done at the same time, just like you would do with a typical vector addition or vector multiplication as well. And that's why I usually stress for arrays. And it also has the added benefit of having a C backend. So it's more of Python when you think about it. So it tends to be faster and it tends to be very, very convenient when you're working with very large data sets. You'll tend to see a lot of your machine learning algorithms will be based on NumPy and SciPy. So understanding how to work with NumPy arrays does really, really help. Cool. Second thing is understanding how to work with tabular data on Python. And here I'll talk about pandas as the library you need to learn. So pandas tabular data. Right after that, we also want to go ahead and learn a lot on data visualization. So now we know how to work with Python arrays, right? It makes it easier for us to do any executions with our data. And then we now learn how to work with pandas. Here is where you'll tend to learn a bit about data analysis, data cleaning as well, because pandas allows you to do that. It's as if you're working on an with an Excel sheet on Python. So that's usually the beauty of pandas over here. Okay, and then after that, you want to now start visualizing your data. So as I'm doing my data analysis, as I'm doing my cleaning, as I'm filling out my missing values, I'm dropping in repeated columns as well. You need to start visualizing your data. So visualizing your data in graphs allows you to get insights from them. It also allows you to understand your data better. So visualization is a very essential skill when it comes down to data science. Some of the libraries we use for data visualization will be things such as Matplotlib as well. We have Bokeh, which is quite interesting. Let me talk about Seaborn as the second one, which is also very, very common. Bokeh and then Plotly. I'd personally recommend learning Matplotlib, and right after learning Matplotlib, learning Seaborn, and then you can learn Bokeh or Plotly as a bonus. And then after that, that's just a general overview of Python data analysis. The general skill you want to get as you're doing Python data analysis is how can you be able to do exploratory data analysis with Python. Analysis with Python. And as you go through any particular data science pathway, you'll start seeing people explain what EDA involves and what you should be doing at each and every single stage, whether that's the data sourcing. So when you think about the EDA process, you want to source your data, right? Right after sourcing your data, we want to do a bit of data cleaning to it. And then we want to do a bit of analysis, whether that's grouping data into pivot tables and whatever you want to do over there. And right after that, we also want to visualize our data. Cool. And once you visualize your data, the loop continues. So based on the visualization, it allows you to see some gaps. Probably you visualized it and you saw there was some missing data off of your visualization, or the graph does not make so much sense. You need to make it make more sense. Probably you need to do a bit more data analysis. You need to create a new pivot table over here. Probably it was time series data and the visualization was not as accurate. It wasn't as clear. So you go back to your data cleaning and data analysis until you have a good output that gives you a proper insight of the data. Some of the things I'm talking about, you learn more profoundly when when you already have a proper understanding of Python data analysis. Cool. The other thing we probably want to cover out when you're talking about data analysis, and now this is not just Python data analysis, these are other general data analysis skills. Cool. It's a bit sad for anyone to be a data scientist yet they don't understand Excel. So having an apt understanding of Excel is usually very, very recommended. Most companies still rely on Excel sheets for handling data a lot, particularly if you end up being a data scientist in a business. So most of them will rely a lot on Excel sheets. So having a proper understanding of Excel helps. But I will recommend additional data tools that help you in your data science journey. A good example is Tableau that we use for data visualization. You might have heard of a tool such as Power BI by Microsoft as well. So we have a couple of data tools that people are using now and then. I personally will always recommend all data scientists to be familiar with Excel and also be familiar with Tableau because those are very two common tools when it comes down to the data analysis stack you'll be going through. So far, we've covered two skills. Anyone with a question for me? Cool. The final thing, I'm going to just copy this. Okay, let me Control Z that. So let me just do that. Copy that new slide so that we can start afresh here. There's one thing I have left out that I want us to clear out, and I'll still add it to the data analysis bit. For data engineers, this might be more profound. And the one thing I might have left out here is SQL. Knowing how to do data analysis with Python is great. You'll need that a lot. It has the libraries for that as well. But most of the time, you'll also be working a lot with SQL-based databases. And it's recommended that you have an apt understanding of SQL queries, how to structure databases with SQL. And sometimes you'll tend to do your data analysis with SQL in the first place. So that's the data filtering. Because you're working with SQL databases, having an apt understanding of SQL as a language, as a query, and SQL databases, whether that's MySQL, as MySQL or Postgres, does help you. So learning SQL programming is very, very key, and learning how to play with relational databases is a very essential skill for any data scientist, because most data analysis tasks will involve either your Python skills, your SQL skills, and some of the tools I've mentioned over here. Okay, if you have a question, feel free to stop me and we can get down to that. So based on what I've already talked about, if you know how to program in Python, you know scientific Python, those are the libraries I've talked about for data analysis, and you're very, very good with SQL, right? And probably you add in a bit of Excel and Tableau skills there, you're good to get a job as a data analyst. Most data analyst jobs will tend to involve those skills. However, the real data science now starts when you now start getting to machine learning. So machine learning is what would I call machine learning? So in the past, what people used to do is we used to code in rules to a computer so that if the rules are fulfilled, you have a particular output. But that's not usually a scalable way. Think about if we want computers to recognize what dogs are. Before, if it was in the 60s, before we had like the whole concept of machine learning, let's talk about the 40s. Someone would take in a computer and start typing in rules and say if they have a head that looks like this, and they're this size in length or height, and the color is probably brown or black or this, then that's a dog. But when you start thinking about it, when you get to very, very complex things such as defining a dog, the rules for knowing whether something is a dog or not are endless. And it's virtually impossible for anyone to ever code in hard in rules so that a computer can be able to identify if an image contains a dog or not. So the big advancement here was how we can structure out computers such that instead of us coding in hard rules onto them, we just serve it a lot of data with images of dogs, and the computer can learn through these images of dogs. And the next time I ask it whether the image contains a dog or not, it can easily know that because it's learning from the vast amount of data that has been sent to it before. And that's pretty much the basis for machine learning. This is the big idea that we are feeding data into a particular model with the hope of trying to make future predictions. And once the computer has been able to learn from the base data. So what we do here, we feed in data to a computer. The computer learns. So we have a lot of learning over there. And once the computer learns about it, so it learns about how dogs look like from the a million images of dogs we've served it. And once it learns, it's able to make predictions in the future. And yes, so that's the big idea here. So I take in a million images of dogs, feed it to my computer here. Computer learns and understands like typically how dogs look like from the million different images. And now when I serve it another image of a dog and I ask it another random image, one that has a dog, one that doesn't have a dog, and I ask it whether it has a dog or not, it should be able to make a proper prediction. That's the big concept of machine learning. Cool. So in machine learning, you'll tend to learn libraries such as sklearn. So that's scikit-learn, which is what you'll use a lot for your machine learning tasks with Python. Another very key library that's very, very important, but you'll tend to use it more for deep learning as well, will be TensorFlow. So these are some of the different libraries you'll tend to use for your machine learning and a bit of deep learning tasks as well. When we get into deep learning bias, you probably want to also have an idea of Keras. I think PyTorch is also really coming up as a library over TensorFlow. So there's that. So let me talk about this right now. I don't want to go extra deep. I think SciPy is also a very essential library because it does have certain models and it also helps. So what do you need to learn on the machine learning aspect? So as you're learning machine learning, the key skill that you probably want to get first of all is sharpen up your math skills. On math, you want to have an idea of linear algebra. You want to have a proper understanding of multivariable calculus. And I think convex optimization is also a skill that's quite needed over here. But before you talk about convex optimization and that, because most of you will not be designing algorithms anyway, let me just say matrices is a very, very key aspect for that. Cool. Most models are designed based on math concepts. So if you already have an idea of the mathematical concept, it's very easy to understand what different machine learning algorithms do. So let me say not models, we're talking about algorithms here. Most algorithms are designed based on the following mathematical aspects. And for you to understand what different algorithms do, having a clear understanding of math allows you to understand the underlying working around particular algorithms. Second skill you want to have here will tend to be statistics, right? Most of the models we are creating here will be based off of statistical concepts. The only difference now is we're implementing it on a computer automatically. So if you're already a statistical expert, you already know what regression is. So you know what to expect when it comes down to that. You know what Bayes' theorem is. So when you're given a model such as K nearest neighbors that uses a bit of Bayesian theory in the execution, you have an understanding of that. So statistics is how the ML models are designed. They're based on statistical concepts. So you understanding statistics allows you to know when to use certain models, right? Yes, it allows you to even do better hyperparameter tuning, which is when you're trying to optimize your models for accuracy. Once again, I don't want to focus on the jargon over here. I just want to focus on the roadmap, so what you need to cover individually to get there. So I would recommend learning your typical inferential statistics. So you want to be okay with inferential statistics. You want to be okay with probability as well. I think this will tend to be the main ones. What am I leaving out? So if we talk about inferential statistics, your mean, mode, your typical statistics for data analysis. You also want a bit of probability here. I would also talk about a bit of advanced statistics. You want to be okay with things such as regression and those concepts. I think I'm missing out the name of the topic here. So I'll put this in red, and with the resources I send in, I'll be able to communicate this better. Cool. At times we just miss out on the naming here. So here I'll just go ahead and talk about some of the advanced statistical concepts that you probably need to be familiar with as well. So those are your base skills as you're getting into machine learning. And now when you get to machine learning, what are some of the typical types of models you need to learn about? So we usually have two types of models. One, we have supervised learning models, and then we have unsupervised learning models. So on supervised learning here, there's two sort of problem sets you'll be working on. You'll either be working on regression problems or you'll be working on classification problems. Those will tend to be the bulk of whatever you're working on there. On the unsupervised learning aspect, now I can't talk about pretty much everything here, but I'll talk about some of the common ones. So you want to learn a lot on dimensionality reduction. So this will tend to have different names. When you're learning about it in mathematics, you'll hear about principal component analysis. So very, very key concept here. One of the key unsupervised learning models you should be familiar with. I'd also clustering is also a very common machine learning problem here. So how to do clustering in the first place. And you can go ahead and start learning more of other unsupervised learning concepts. You'd start hearing of things such as association baskets. However, I'm not going to talk about this. For you to just have that base entry into machine learning, knowing regression problems, classification problems, and the different models you can apply on each is really very, very key. And then also understanding unsupervised learning, that is dimensionality reduction, feature engineering in simpler terms, and clustering also gives you a proper understanding of that. So there's always a higher depth that you can get into. I'm just mentioning some of the common ones. Those are pretty much the four most common problems. After that, I'd recommend understanding time series analysis. So here, instead of working with sklearn, you'll tend to work either with TensorFlow if you're working on the deep learning aspects of it, but you can also work with a library such as StatsModels. So time series analysis is also a concept by itself that you want to understand it, because here you'll be working on different sort of problem sets here. Most of the common words we hear will tend to be your autoregression, moving averages. So you'll be working on AR, MA. So I'm just trying to mention them in short before you get to ARMA, RIMA. And you also want to start understanding things such as Arch and Gach as well as you get into that. I'm just mentioning a very, very short overview, but you guys will need to focus your time as well on time series analysis. A lot of the predictions we do on a day-to-day basis will tend to be based on time-based data from time to time. So it's quite a key concept to learn. And if you want to go an extra mile, not actually an extra mile, the other key concept that I'm forgetting is, as a machine learning expert, you want to be able to evaluate your models. So model evaluation is a very key thing, and how you can tune your hyperparameters to increase your accuracy. So model evaluation is more than important, and I'll also add in deployment as a key thing. Knowing how to evaluate a model is okay, but more importantly, knowing how to deploy it to a web app once you've evaluated it is also a very, very important skill for data scientists. And once you're comfortable with all that, you have the option of getting into deep learning, where you start working with neural networks to pretty much do some of the problems we've already talked about in supervised learning, unsupervised learning, and time series analysis. So instead of doing it with your typical ML algorithms, you can also do it with neural networks. That's usually now going an extra step. You really want to be a proper machine learning engineer. That's it. But most of the scientists will tend to only know number 1 to 4. And deep learning is really a good step to take because it allows you to understand how to work with neural nets. With neural nets, that's when you start learning about computer vision, start learning how to handle audio data. At least you can handle more complex data when it comes down to neural networks, right? Because they'll tend to be way smarter than your typical just machine learning algorithms. Okay. Any questions up to there as we close off on machine learning? Cool. So, what are some other things that I'm missing out that you should probably give an eye to? So let me just talk about the extras. We have a proper understanding of machine learning. We have a proper understanding of Python programming in data analysis. We have a proper understanding of how to work with databases. And we're just trying to cap up our knowledge with the next step. So the next step for us will be to understand data pipelines pretty well. And that's where data engineering becomes a very, very important concept. I think there's one person who mentioned they're a data engineer. I didn't get your name right. You could tell us more about what your job description is. I wish so. If you can type it down, and then we'll hear about that. Cool. So once you're okay with machine learning, you're okay with data analysis, you're okay with Python programming, I think you can, I would say, and I'm going to do this over here. Let me go ahead and remove deep learning here. That will leave model evaluation and deployment. Okay, so I think I've gone through the general data science pathway so far, right? At least in brief. So let me talk about the extras that you could go through. So the first extra that I've already talked about is getting into deep learning. And this is whereby you're trying to implement some of the same ML problems, about with neural networks. And some of the libraries you want to learn to be able to do this will be TensorFlow, PyTorch. Those are the two common ones as well. I think you guys might have heard of things such as Theano or Keras as well. I would say focus your time more on TensorFlow and PyTorch. So that's usually a big skill. If you think you like machine learning a lot and you want to get into deeper neural networks so that you can start working with complex data and start kind of boosting up the accuracy of your models to the next level, neural networks are better tuned than just hyperparameter tuning we see with machine learning as well. Then you can get into deep learning here. Cool. Some of you will tend to appreciate their time working with databases here when you talked about SQL, right, and the data pipeline there in terms of the data collection and a bit of cleaning and trying to make sure you're able to handle big data sets. So when you talk about data engineering, most of the time you're talking about big data here. And we also want to talk about how you can start handling big data. And these are the people who want to be on the pipelines. You're the enablers of the people who want to do more ML engineering. Without the data, these people are useless. So this is a very, very common career pathway, very, very high paying career pathway, and one of the biggest areas for growth in the future because we are collecting a lot of data as the world today. But the big idea is, are we able to create data pipelines for collecting real-time data so that we can start serving our models to make better predictions? As everyone is thinking about machine learning and AI, data engineering is becoming more of a bigger need across different businesses. So you'll tend to see data engineering is quite on demand as a career by now. So with big data here, some of the things that you should probably look at will tend to be Hadoop. You also want to look at Spark. So you're talking about Apache Hadoop, Apache Spark. You can go and also learn a bit about Apache Kafka. I'm just talking about the three main ones over here. And just having an understanding of this big data tools would really, really help you in your data engineering career, where you'll either be working on, you'll be working majority on some of these tools as well, on top of your typical SQL skills and database skills as well. So data engineers will tend to work a lot on the data pipelines. Cool. Another extra, and this I wouldn't really call it an extra. I think anyone who's in tech today should be well versed with cloud computing. Do you know how to deploy your models on the cloud? A lot of companies are using the cloud today as well, right, on a typical mobile application. So I would say, let me call model deployment could be an extra where you want to know how to deploy it with Flask or Django, but most of the time you'll work in a team, so the web developers will tend to do more of the deployments there, the machine learning engineers. But understanding how to just deploy a typical model on the cloud is very, very key. Some of the cloud platforms are quite popular that you should be familiar with, at least understand the cloud architecture behind this and where you fit in it with your ML algorithms or how you deploy data or how, like the tools you need to use for all your data science tasks as well. So learn about AWS. We also have Microsoft Azure, and Google Cloud Platform is also coming up very well. Some other ones that are still good will tend to be IBM, a bit on Oracle, but I'll tend to focus my time on the top three. That will be AWS, which is the market leader, Microsoft Azure, which is coming up very well, and Google Cloud, which a lot of people have not upskilled into Google Cloud, yet it's really, really coming up. So people who have an understanding and of Google Cloud and they know how to play around with this cloud system, whether that's for data science or web development or software engineering, you'll tend to see that there's a lot of on-demand jobs coming in. You tend to earn more because there's limited talent over here, whereas everyone else is learning AWS because it's the market standard here. So yes, you'll expect more jobs with AWS, but I would say because there's less talent on Google Cloud, you start seeing, I'm not saying there's very, very low talent. There's still a lot of talent out there, but not as much as AWS. So when companies are using Google Cloud, they'll tend to pay a higher premium for that. Cool. So that's just an overview of data science as a career. I think I've covered some of the key aspects here. If I've missed out on any particular thing, I'll probably communicate it on email as I share the resources. I think the resources should just be as detailed as well. And I hope that by understanding the pathway that I've talked about today, you'll be able to chart up your data science career very, very simply. So I'm going to do it all in a summary, right, of what I've talked about. The most used programming language for a lot of data scientists will be Python. That's why I've recommended Python as the programming language to focus on. And pretty much everything else you do on the data science stack will tend to use Python. So as a summary, here's the minimal, let me just call it about, just in brief, what I've talked about. One, I've said Python programming is the programming language you want to upskill into for your data science career. After that, you want to learn Python data analysis. And here we talked about learning libraries such as NumPy, Pandas, Matplotlib, Seaborn, and I said those are probably the main ones here. And then we talked about understanding data tools. And some of the data tools that I recommended for you guys was Excel and Tableau. I also went ahead and stated that for any data analysis job and data science job these days, particularly if you either want to be a data engineer or a data analyst, most data is being served from SQL databases. So having a proper understanding of SQL programming and relational database bases does help you. It's a very, very essential skill. At times you'll tend to do data analysis with SQL instead of Python. So it's a very essential skill a lot of jobs require. Like Python and SQL will tend to be the requirement for a lot of jobs. At least for Python, you can opt for R, but these are pretty much two very important aspects, at least for data analysts. So up to here, we said you can handle a data analysis job so long as you have a good understanding of business knowledge based on the industry you're working in as well. And you have a good understanding of statistics a bit, and you're pretty good at generating insights off of it. The other things you learn on the job as well, but these are some of the key skills for data analysis. After that, we stated that you now get into your machine learning tasks. And in machine learning, we talked about you learning about different machine learning problems that we solve. So that's typical regression. We're thinking about classification. After classification, we talked about PCA, that's principal component analysis or dimensionality reduction, and a bit of clustering. Some of the extra tools, skills I talked about here would be model evaluation and deployment. Model evaluation and deployment, very, very key skill there. And finally, I gave you guys ideas of where you could opt into. So before I talk about where you should jump on next, it's going to be cloud computing, where you can learn in AWS or Azure. So let me talk about AWS, GCP, that's a Google Cloud Platform, or Microsoft Azure. We'll call this cloud. And then number 8, I said, based on where you think you're interested most on, you can decide to specialize either to become a data engineer by learning your Apache Hadoop, Apache Spark, Apache Kafka, and getting your SQL level to the next level. Or you could opt to start focusing more into ML engineering by getting deep into deep learning as well, by either learning TensorFlow or PyTorch. Cool. I hope this gives you guys a general overview of data science as a career and the roadmap by itself. I might have missed one or two things in the process there, but I will send you guys the slides and the video recordings so that you have a proper understanding of what we've talked about, and also share resources where you can get started if you want to take up this pathway. Thank you very much. Let me open it up for a couple of questions. Any questions? Any questions?